Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video we are going to study about the ultrasonic type level measurement. Here we will study the principle, its construction, advantages, disadvantages and limitations and applications of ultrasonic level sensors. So let us start with our topic. The measurement of the level of a liquid is a very important function in industrial processes. Industrial processes, they involve various types of liquids like the water, the chemicals and the solvents. So to find out the amount of liquid, we find the level of the liquid in a container. So if we are saying that liquid level, so liquid level refers to the position or the height of the liquid above a datum line. So liquid level is defined as datum line, or we can say the reference line. So to find out the amount of the liquid, we find the level of the liquid contained in a container or a vessel. So suppose that it is the vessel or the container in which we are having the liquid. So to find out that how much amount of liquid is present in this container, we find the level of the liquid in this container. What we do, we take the bottom of the container as our reference line and the height or the position of the liquid above this reference line is the level of the liquid. So through this you can see that the measurement of the level of the liquid is a very important function in the industrial processes, because there we want to find out the level of the chemicals, the level of the solvents, the level of the different gases and the different solid materials also. Okay. Now this liquid level, it does not only affects the amount of the liquid, but it also affects the pressure and the rate of the flow in and out of the container. So level affects pressure and rate of flow also. So by measuring the level of the liquid, we can measure the pressure and the rate of flow also of the liquids. Now this measurement of the level, it is done by two methods. One is the indirect method and other is the direct method. In the indirect methods of level measurements, the level is not measured directly. It is converted into some other measured signal, and that signal is measured with the help of some transducer. Okay, so level is measured by measuring some other physical quantity, not directly measured. Whereas in direct methods, we get a direct indication of the level of the liquid by using some mechanical devices, and examples of direct methods are direct indication of level. Okay, and examples are floats, the sight glass method. Okay, so all these, the dipstick method also, these are all a type of direct methods. Now about the indirect methods, we are having the capacitive, the hydraulic hedge type methods. So all these are the indirect methods, because there the level is converted into some other measured signal. Like in capacitive type level sensors, we measure the level by measuring the change in the capacitance. Okay, so that is an indirect method, and direct methods, they give us the direct indication of the level of the liquid. Now in this video we will study about the ultrasonic type of level measurement, which is a type of direct method of level measurement. So in this method we will get the direct value of the liquid level. Now these ultrasonic type of level measurement methods, they basically use the sound waves. Okay, sound waves are of two types, means that the waves which can be heard by the human. The humans, they can hear the sound waves in the range below 20 kilohertz, whereas the ultrasonic waves, they are in the range from 20 kilohertz to 200 kilohertz. Okay, so ultrasonic type of level measurement methods, they use the ultrasonic waves for the measurement of the level, and these waves are not hearable, are not in the hearing range of the humans. You can see that the bat, the animal bat, it cannot hear the human voice. It can hear the ultrasonic waves, and with the help of ultrasonic waves, because bat cannot see, so to find out the distance of any object which is far from the bat, he uses the ultrasonic waves for that. Bat generates ultrasonic waves, and when that waves strike the object, they return back. So the distance or the time taken by the ultrasonic waves to get hit the object and return back, that is calculated by the animal bat, and in that way he calculates the distance of that object from itself. Okay, so the same principle is being used by the ultrasonic type level measurement methods. There also the ultrasonic waves are generated. They are these waves are going to strike the level of the liquid and return back, and the time taken by the waves to strike that object and return back will be calculated to find out the level of the liquid. So as I've said that the ultrasonic waves, they are in the range from 20 kilohertz to 2000 kilohertz. So the ultrasonic level sensors, they use the frequency range from 40 to 200 kilohertz. So this range is used for the measurement of the liquids. Generally we can measure the liquid level for the hot, corrosive and the boiling liquids. So now let us see the working principle of the ultrasonic level sensors. So this is the ultrasonic transmitter which is generating the ultrasonic waves. Also it is receiving the waves also. So it is acting as both the transmitter and the receiver. This is the ultrasonic pulse beam which is generated by this ultrasonic transmitter. This is the tank wall and this is the process fluid. Now when these ultrasonic waves, they are going to strike the top of the liquid, they are going to return back. First the rays will be generated. After the reflection from this level of the liquid, they are going to reflect it back and again received by this ultrasonic transmitter and the receiver. So the time taken by the ultrasonic waves to strike and return back, that time will be calculated and the time taken will be equal to the level of the liquid in this tank. So that is the principle, working principle. So here we have described the working of the ultrasonic level sensors. Level sensor is located at the top of the tank. This sensor is going to send the sound waves in the form of burst in downward direction to hit the in downward direction towards the fluid which is filled in the tank. Now as soon as these waves they hit the surface of the fluid, these sound waves they get reflected and echoes are generated. These echoes they return back and they are received by the sensor again. Okay, so the time taken by the sound wave to return back to the sensor, that is directly proportional to the level of the liquid in the tank. So time is directly proportional to the distance between the sensor and the fluid, and this sensor is going to measure the time duration which is then further used to find out the level of the liquid in the tank. Because when the tank is empty, then more time will be taken for the echoes to get returned back to the sensor, and if it is filled with the liquid then less time will be taken. So by comparing these two times we can find out the level of the liquid in the tank. Okay, so we can say that time duration is measured by sensor. So this time duration is measured by the sensor, which in turn is used to further calculate the level of the liquid in the tank. So in this way we are directly measuring the level of the liquid. So it is a type of direct method of level measurement. So this was the operating principle and the working of the ultrasonic level sensors. Now let us see some of the features of these ultrasonic level sensors. Now these ultrasonic level sensors, they use frequencies in the range of tens of kilohertz, that is from 20 kilohertz, that is from the 40 kilohertz to 200 kilohertz of range, or we can say that above 20 kilohertz of frequency range can be used. The transit time is approximately 6 milliseconds per meter, and the speed of the sound, it depends on the mixture of the gases present in the headspace, means between the sensor and the level of the liquid, that what is the composition of the gas and also what is the temperature of the gas. So the first the feature is that here the speed of the sound, it depends on the mixture of the gases in the headspace and their temperature. Okay, so to reduce the effect of the temperature, these ultrasonic level sensors, they must include a temperature sensing device which is continuously measuring the temperature of the gas which is between the sensor and the liquid level. Okay, so that we can get the correct measurement of the distance and the time, and we can get the correct measurements for the level also. Now there are some cases in which the fluids in the industries, they have a heavy foam over their surface. Now this foam is to be avoided because this foam act as a very good sound absorbent. So when the ultrasonic waves, they are going to hit the surface of the liquid, these sound waves are sometimes absorbed by the foam. So the reflected echoes, they will be affected and the measurements of the level will be affected. So in that cases where we are having the heavy foam, it should be avoided, it should be removed from the surface of the liquid, then only the measurements can be taken and correct and accurate results will be obtained. Surface of the liquid is wavy, or it is having very much variations, it is not in a level, then also it results in the fluctuations in the level measurements. Okay, so excessive surface turbulence means that when the container, it is not kept on a flat surface, it is continuously moving or shaking, so the level of the liquid is also changing, and due to that the fluctuations in the measurements can result. So if we want that the measurements are good, the measurements of the level are accurate, so it is required that the reflected echo, it return back in a straight line to the sensor. So when the beam is generated by the sensor, it is going to get reflected back by the surface of the liquid. So when it is returning back, reflected back, that echo should be in a straight line to the sensor, then the measurements will be good. Okay. So these are some of the features of the ultrasonic level sensors. Now let us see some of the advantages of these sensors. Now, as these ultrasonic level sensors, they are of non-contact type or contactless sensors. They are not making any contact with the liquid whose level they are measuring. So they can be used for the measurement of liquid level of very hot, corrosive and the boiling liquids. Okay, because if other instruments are used for their level measurement, those instruments get damaged. But ultrasonic level sensors, they are contactless, they are non-contacting type, so they can be used for the measurement of liquid level of such liquids. Also, these ultrasonic level sensors, they consist of fixed components, no moving parts are there, so no friction problem is there, and they require less maintenance. Also, these sensors, they are mounted at the top of the vessels, so due to which they are less affected by the leakage problems. In other sensors which are dipped into the liquid or which are in contact with the liquid, leakage problems can occur, but in ultrasonic, because the sensor is mounted at the top of the vessel, so no leakage problems are there. So these are the advantages of the ultrasonic level sensors. Now comes the disadvantages. So there are some disadvantages of ultrasonic level sensors also, because many factors can influence the echo which is received back by the sensors, like the heavy vapors, surface turmoil, foam, materials like powders, noise and temperature. So the time taken by the echo signal to return back to the sensor, that will be affected, and due to that the level measurement is going to get affected. Okay, also the ultrasonic waves, they are very harmful. Okay, so the use of this ultrasonic level sensors, there are some restrictions also, like they cannot be used in the high pressures and vacuum conditions. Okay, and there are some drawbacks of this sensors also. So in this video, we studied about the ultrasonic level sensors which are used for the measurement of the liquid level. Directly the level is measured by measuring the time taken by the sound to return back to the sensor. We studied its operating principle, its construction, its advantages, disadvantages and some of its features also. So I hope that this topic is now clear to you. Thank you.